So I wanted to go over a few things from Chapter 5 just to clarify some of the questions that students have been asking me over the last few days. I noticed on my test review, this is a problem on the front page. Numbers 10 through 13 dealt with this diagram right here, and I misinterpreted the diagram when I looked at it the first time. I thought that the 11 was referring to this segment, which means all of these are 11. And I know some of you thought that also because the diagram is not drawn very well. However, if you look at this triangle in here, that's a right triangle with sides 24 and 25, the hypotenuse being 25. So if you were to do the Pythagorean theorem on that triangle, you would have x squared, meaning the x is that side, plus 24 squared equals 25 squared. And that will give you that x is 7. So where I have this 11 marked here, that should not be 11. That's actually 7. So these are all congruent and they're all 7. The 11 is referring to this hypotenuse of the triangle. So this 11 is actually here. Okay, so when you are looking for dB in problem number 11, I said there wasn't enough information. That's because, again, I had thought that the 11 was referring to the radius of the inscribed circle. And so in that little triangle, you have that right triangle. It would be leg of 7, hypotenuse of 11, and you're looking for this length. So it would be y squared plus 7 squared equals 11 squared. And then you can solve dB from there. Some students also ask me how to find 32-degree angle. So for angle HAC, what I did was, because they told you in the problem that this was an in-center, you know that these are angle bisectors. So if this one's 30, the other side of the angle is 30. If this one's 28, the other part of the angle is 28. And then that makes this large angle 60, it makes this large angle 56, and you can see that I'm adding up to 180 to figure out the big angle here at vertex A, which is 64, and then again you can cut it in half and you'll get your 32 degrees. Okay, and then someone else asked why it's not possible to do number 16. Well, number 16, I think they intended to ask you a question that would be the converse of the hinge theorem. However, for the converse of the hinge theorem, you need pair of sides congruent in two triangles, second pair of sides congruent in two triangles, and then if I tell you, like let's say this is 6 and this is 9, you can tell me that the opposite angle in this triangle must be larger than the opposite angle in the other triangle. But you don't have the hypothesis of the converse of the hinge theorem in problem number 16 because we don't have the congruent segments that we need. We're supposed to be able to say that we have two pairs of congruent segments, so it's supposed to be that there's a pair of congruent segments here, and there's a, no wait, hold on a minute. We're trying to compare angle RST and angle JKL, so we're trying to compare those angles. So it would be like you have these two congruent here, and you have these two congruent here, and then the included angles can be compared by looking at the third side length. However, we don't have the congruent sides that we need, so that problem is not possible the way that it's drawn. Okay, I had a few questions about the problem number 9. It said that the measure of two sides of a triangle are 3.1 and 4.6 feet. What is the least possible whole number measure for the third side? Now, for this problem, most of you remember that you get your inequality by doing 4.6 minus 3.1. That tells you the third side needs to lie between the difference of the two and the sum of the two. So when you add those, that would be 7.7. So that's where this inequality comes from, and most people are okay with that. The problem comes in interpreting what it's saying. When it asks for the least possible whole number measure, they're saying, okay, the third side needs to lie somewhere between 1.5 and 7.7. So we know that it can't be 8 because 8 doesn't fall within that inequality symbol, that range of values for the inequality. But some students were confused why it was 2 and not one of the other answers. So, or for example, like 1.6. A whole number means no decimals. So no decimals means you can throw out 1.6 and 7.5. It's got to be 2. Why is it 2? Because 1.5 is kind of the lower bound of your x values, and we're rounding it up to the next whole number, so it would be 2 feet. All right, number 31. This is a problem that's like one that was on the last quiz that so many of you had trouble with. So there's sort of two different ways you can kind of approach this. Here's what you cannot do. When you have two different triangles, say I have two different triangles here, and I know that this angle measure is 100 degrees, and I know that this angle measure is over here is 30 degrees. You cannot say that because this angle is larger than the 30-degree angle that the opposite side has to be longer. That's just not true. Okay, in two different triangles, you are not going to be able to compare how sides are in relation to the angles that are opposite them in the different triangles. So within one triangle, you can say, okay, look at this triangle. In this triangle, BCD, we know that the smallest angle is 40, therefore the shortest side is CD. We know that the longest, biggest angle is 80, so the longest is going to be BD, and the medium one is BC. So we have this inequality for this triangle. Now for our other triangle here, and this would be triangle ABD. We know that the shortest side is off the smallest angle of 35. So looking at this triangle, the shortest side will be the BD, that's across from the 35. The biggest angle is 75, so AD is the longest side, and then in that triangle, AB is the medium side. Now, when you try to compare sides of the two triangles, you have to have a shared side to be able to jump from one to the other. So this BD in the middle here provides us a way to kind of combine the two inequalities together. So CD is less than BC, which is less than BD, and BD is less than AB, which is less than AD. So you can put them together because BD sort of links the two. It's kind of like a transitive type of thing, and that would tell you that the shortest segment in the whole diagram would be segment CD, and the longest segment in the whole diagram would be segment AB. Okay, so notice that AB is across from a 70-degree angle, and BD is across from an 80-degree angle in the other triangle, but AB is actually longer. So it doesn't make sense to compare, again, this situation when you have all you kind of are knowing is the angle measures in two different triangles. You can't say cannot say that that makes this side longer than this side. Other issue, this is not the hinge theorem. Some students were thinking that, I saw this on a lot of papers, that the one that says that the shortest side is across from the smallest angle is the hinge theorem. That's not the hinge theorem. That theorem doesn't have a name. It's just a theorem that says that in a triangle, small sides are across from small angles and big sides are across from big angles, etc. That's not the hinge theorem. Again, the hinge theorem is if you have these congruent and those congruent and you know this angle measure compared to this angle measure, then the opposite side here can be compared to that one by saying that this one is smaller and that one's bigger. That's the hinge theorem. The hinge theorem requires two different triangles. We're not talking about two angles in the same triangle. Okay, and then the last situation is the ones where you're looking for the range of possible values for x. So we've got the hypothesis of the hinge theorem satisfied. So we have a pair of congruent segments here. We have the reflexive sides congruent there. And then we found, because of the 90-degree angle here, you can get your 30 degrees down at the bottom, which will leave us 55 up here, and then 60 over here. So the 60-degree angle is going to give you a segment across from it that is bigger than the one across from the 55. So that will be this inequality Here, 5x plus 3 will be bigger than 3x plus 17, and that will tell us that x has to be bigger than 7. Now, with the sides, side lengths need to be positive. Okay, so generally I'm going to write this other inequality that says that whatever things are expressed by side lengths, they have to be greater than 0. In looking at this problem, actually, because x has to be bigger than 7, when you put numbers bigger than 7 into these expressions here, they're all going to be positive. So you actually don't really need to do this inequality on this particular problem. But if you did, it really just kind of ends up giving you the same answer you would have if you didn't. So this ends up being your answer in the end anyway. Okay, now if you do it that way, if you go ahead and write that inequality, you just graph it and say, okay, here's negative 17 thirds, here's 7, I need numbers bigger than 7, I need numbers bigger than negative 17 thirds. Where do they overlap? It's everything over here, so it's numbers bigger than 7. And then lastly, this one is the converse of the hinge theorem. We have the congruent segments, congruent segments that we are given in the reflexive side there. And then we've got in this triangle a 41-degree angle that's across from a 54-degree length of 54. And then we've got an angle that's x plus 20 that's across from a 28 length segment. So we know that the x plus 20 is going to have to be smaller than 41, so x is less than 21. Okay, now the other situation is your angles have to be positive. Not only do they have to be positive, they also have to be less than 180 degrees. So each problem you just kind of look at it separately and decide, is this important for this problem or not? Well, if x is less than 21, you need to be careful, because if you take numbers too much smaller than 21, you'll make your angle measures go negative. So x plus 20 is the only angle in the problem, the only thing that has the x in it. And if you put in a negative number, like let's say negative 5, it's going to stay positive. But if you put in a number like negative 100, negative 100 plus 20 is going to give you a negative angle measure in the x plus 20 angle up here. So we need to make sure that not only do we have x is less than 21, but we also have like a cutoff that says that the angle measures won't go negative. So your second inequality here needs to be that x plus 20 has to be greater than 0, which means x is greater than negative 20. And that's the second part of your requirement for the inequality. So we need numbers that are, final answer here, numbers that are between negative 20 and 21. So again, the less than 180 situation, you don't need to worry about that, because when you look at the fact that x has to be less than 21, that means that we're not going to have an angle, because if you use numbers smaller than 21, this x plus 20 will not go over 180. If you do write that x plus 20 has to be less than 180, it says x is less than 160, then you just, again, graph it on the number line. Here's negative 20. Oops, sorry about that. Here's negative 20. Here's 21. This is not on a scale by any stretch of the imagination. There's 160. So less than 21 would be that way. Greater than negative 20 would be that way. Less than 160 would be that way. Where do they all overlap? Right here. Oops, sorry. Right here in the middle. So it's the numbers between negative 20 and positive 21. So those are just to clarify a few things that have come up in conversation the last few days. I hope that you find that helpful.